Okay, now that we have get a sensing of what we are going to plan, we are going to fill up the template, and I'm going to use this video to show you how should your instructions looks like. So you're going to write the instruction to actually direct an experiment, right? So first you need to state what are the independent and dependent variable. So in this case, we are going to change the volume of water, right? So we are going to fill up different volumes of water, room temperature water. So because of that, your independent variable will be the volume of water, and we are going to write that in a very specific format. We are going to describe what it is, what is the symbol it is going to take, and what is the unit that we are going to use. So in this case, we are going to talk, say, volume of water. Let's see if I can borrow some of the phrasing in the question paper. So okay, so it's in cm cube. It is called water in the styrofoam cup. So let's do that. Water in the styrofoam cup. It is going to take the symbol. So we are done with the description. So now the symbol is capital V, and the unit we are going to use is cm cube, right? Dependent variable, it is not just temperature, it is the highest temperature, right? TH. So we need to follow this. So we need to take the hints from there. So you don't need to come up with your own. So for me, I always refer. So it's not just the temperature, but the highest temperature of water in styrofoam cup. The symbol is TH. Okay, and when you are writing the variable, it is very important that you remind yourself that this must be what you directly measured. So it shouldn't be T-boil, it shouldn't be a T rise, or it shouldn't be T drop, and it definitely shouldn't be T drop slash T rise, because T drop slash T rise or T drop itself, for example this, it is process data. So your variable here, it has to be something that can be measured directly. Your control variable, like we have shared before in video 2, that it can be the type of room temperature water, the room temperature itself, the mass of the metal piece, things like that. So your control parameter can be many things. It can be the type of metal, can be the room temperature, right? It can be many things, can be the type of water in styrofoam cup. It can be even the styrofoam cup itself, right? You want to use the same styrofoam cup to keep it as a control. So it can be many things. Then after that, because down here, if you recall, we have analyzed what we should include in our plan, and we can identify that actually this and this are the easiest step to score. So we will not develop the plan in sequence, but rather we will develop our plan according to how easy it is to score a point. So we have already done this. We have set up the independent dependent variable. We have listed down what are the control parameter. So the next thing that is easier to score would be what graph to plot, right? So we will go directly to what graph to plot, and in our earlier video we have already identified that by comparing coefficient, oh sorry, I should use the same color code, right? So by comparing coefficient, we can see that this is the constant term, and the blue color one are my variable. So we are going to plot T drop. Let's write it properly. Since I keep complaining about your handwriting, I should use good handwriting also, right? That I should plot this versus this, right? And by doing so, I have already made a score for this. So the last thing that I want to score, which is easiest, is how to obtain the CM specific heat capacity from the gradient of my graph, right? So I'm going to skip directly that, and I'm going to tell the examiner that by calculating the gradient, I have this expression, and so since you want me to find Cm, I'm going to make Cm the subject, and I will be able to get this expression. Right, and by writing step number 10 and step number 9, I will be able to fulfill this 3 part of my planning. So if you're running out of time, what you should do is that you should answer these 3 points first, and then you leave one of the point last. So even if you couldn't finish the practical paper, out of the 6 mark, I think most likely you are going to score 4 out of 6 already, just by answering this bullet point, right? We answer bullet point 1, bullet point 3, bullet point 4. So once you do that, well, you are safe, right? And if you want to aim for perfection, yeah, then let's do the second bullet point, which is the full description of the instruction that you're going to give to perform the experiment. So now let's write step 1. Step 1 is, of course, to set up the experiment according to the figure that is given to you. So figure 1 and figure 2. And then you are going to use step number 2. You are going to actually describe the action that you need to first do to actually obtain the independent variable, in our case, which is the volume of water in the room temperature, right? So imagine now what happened is that you have a styrofoam cup, and you are going to pour water into it. So maybe, I don't know, pour water into it, right? So you are going to pour a certain volume of water into it. So in this case, just put a dummy value, maybe 20 cm cube of water into the styrofoam cup. And then in this particular step, is very important, it's called the measure and record step. So in the measure and record step, you have to follow a certain format. You need to describe what you are going to measure. So in this case, we are going to measure the volume of water that we pour into it, right? I know it's a bit lame because down here you already said 20 cm cube. But yet, you still have to record this 20 cm cube as a parameter, right? You need to tell the computer or tell the user to save this parameter as V. So in this case, measure and record the volume of water in the styrofoam cup as what parameter? What is the symbol? V. Using what equipment? Using measuring cylinder. So this measure and record statement, you can see it as it consists of measure and record, the action word, and then first component, the description. Then after that, the second component, what symbol will it represent? And finally, what is the measuring equipment? So in order to have the measure and record statement correct, you must have these 3 components. So after you put in the water, what you are going to do is that you have to actually transfer the hot metal into the room temperature water, right? So down here, you need to have the step whereby you transfer the hot metal into the room temperature water. So I think down here, it didn't include that step. So maybe you need to include one more step. So this step basically will describe the action you take to produce the reaction that you want to measure. So maybe here you can say lower the hot metal mass into, oh, in fact, do I need to write? No need, right? I can take advantage of this, right? You can take advantage of this step, right? So if the step is already shown to you, you don't need to copy it word for word, but you can say you can perform step A bullet point 3, right? So here you can just add in perform step A bullet point 3. So you don't even need to copy word for word, okay? It is allowed. Then again, you want to do it for the dependent variable, right? So measure and record. So remember, it's not just the temperature, but the highest temperature of the water in the styrofoam cup, right? As what? As TH, using thermometer, right? So down here, what you can do is that you can include a step to actually make your instruction even better, to reduce the random error. And the standard way of removing random error is to take average. So to take average, you may need to perform multiple reading. But in this case, since we are doing hitting experiment, one of the precaution that we can state in our planning is that we can put in cautionary steps such as transfer the hot metal mass to the water as quickly as possible by bringing the cup near to the hot metal. So this can be considered as one precautionary step. Another precautionary step could be when you bring up the hot metal from the boiling water. Actually, it will be wet, and the water the metal, when it is wet, when you transfer it into the styrofoam, actually you are bringing in additional mass of water. So a precautionary step could be as simple as dry the hot metal mass before lowering it into the cup. So it is possible also. Then after this precautionary step, it is now time to actually get the calculation done. So what we have done so far is that we have asked the user who is reading our instruction, get a one reading, and then after that get the corresponding highest temperature of the styrofoam cup. So what we want to do now is to instruct them to actually calculate this, and therefore record this, right? So now this step over here, we will then ask them to calculate, maybe I will write here, T drop. And we cannot just say T drop, we have to give them the expression. T drop equals to TB minus TH, comma. We also have to ask him to calculate T rise, which is TH minus T room. TH minus T room. Right, then finally we also need to calculate, what do I need to calculate? T drop, TD over TR. So TD over TR will be T drop over T rise. So we will need these three parameter as well, so that the person will be able to fill up this pink color part. So after he calculate all these things, we need to ask the fellow to actually tabulate the reading V, TH, T drop, T rise, and T drop over T rise. So there is 1, 2, 3, 4, 5 of them, and you can see here when we are doing the initial planning, 1, 2, 3, 4, 5. So it should correspond to the column. So once we do that, then what we need to do, what we have done so far in our instruction is that we have asked the user to give me this row of reading in our table. So now we need to tell the user that, hey, after you do this, right, can you change the volume? And then after that, you do this. And then after that, you repeat. And then after that, you do this again. Oops, wrong color. you should do this again, and then you get your subsequent reading, so on and so forth, until you get a total of 5 reading. So because of that, we are going to give the following instructions. We are going to tell them that you should vary the volume of water in your styrofoam cup, right? And then I have to tell him to repeat actually step 3 to step 7, right? Step 3 to step 7, because every step he take, then after that he need to record in the table, right? So therefore it should include the tabulation step, and I should obtain 5 other value of V, right? And then after that he will plot the graph, and then after that he will use the gradient to find the constant that it is looking at. So overall, with so many steps, if you look at this, what we have done is that we have done from here all the way till here, and if you didn't make any mistakes from here to here, then only then you will be able to get the mark for the second bullet point. So that's why the second bullet point is the hardest to get. So out of the 6 marks, right, if you look at this, out of the 6 marks, you can actually choose which bullet point to focus on, right? The hardest one is like the second bullet point, describe in detail. And then the first bullet point, state the quantity, which is constant, sketch the graph. Out of 3 bullet point, you answer 2, you should get 2/3 the mark, right? And I think that you should be happy. I mean, if you are running out of time. So this is your first design experiment. What I want you to do is, of course, to really look at video 2 to understand the pre-planning process. Then after that, of course, remember our strategy, which is to attack the beginning part of the plan and attack the end part of the plan first. And after that, when we have time, we will fill up the flash of the plan, meaning the main part, which is the hardest part, which is to give this set of instruction. Okay, thank you for listening in, and I want to collect your paper